Okay, this is our video for section 5.3, which is the ellipse. And what we've done here is we've got the general shape of one type of an ellipse and the important features of the ellipse. So if you look at it, you can often draw an ellipse with a rectangle and fit it inside the rectangle, which I did here. It's not the best drawing in the world, but it does show what all the important features are. So of course here we have the center, and the center is always H and K, signified by HK. Then C distance away is the foci, the two foci of the ellipse. And of course from the center out to the two vertexes, it's A distance away. So this is A distance from the center out here. And of course we have two distances here that are on the side of the ellipse, and that's from the center to this edge, and that's B distance. And you can see the general standard form of the ellipse here. A squared is underneath the x in this case because this is a horizontal ellipse. If you look over here on the bottom part, a vertical ellipse looks like this right here, and you'll notice that the A squared is underneath the y in this case. And that's how you can tell whether it's a vertical or horizontal ellipse. Look for whichever one has the bigger number underneath. A is larger than B in this case. Also, the relationship that there is between A and B and C is that we have in an ellipse C squared is equal to A squared minus B squared. It's not the Pythagorean theorem, it's just the relationship between those variables in the ellipse. Okay, so this is called the standard form of the ellipse. You can have the general form if you expand this out, and then take these and multiply by a common denominator, and you'll get, and put everything to one side and equal it to 0, and you'll get a general form. And that's what we're going to do today, is we're going to look how to draw and determine the features of an ellipse, starting with this general form here. So here's an example of an ellipse. Now the reason I know that this is an ellipse and not a parabola or something else is that there are two squared values in it, x squared and y squared, and an x and y, and that the x and y squared are different. If it was a circle, x squared and y squared would have the exact same coefficient in front of them. So how do we determine the ellipse's features? Well, we have to put it into standard form. So what we have to do then is we have to take the x and the x squared, put them together, take the y squared and y, put them together, and move the 33 over to the other side. So that's what we'll do first. So you go x squared plus 2x together plus y squared plus 24y. And that's equaling, if we move it over to the other side, negative 33. Then what we do is we take out the factor that's in front of the squares. And we have to do it in two steps. We have to take the x's together, the x squared and the x, and think of those as one thing, and take the y's together and think of them as one thing. So this doesn't have any coefficient in front of the x, so it's just 1 times x squared plus 2x. Yet this one has a 4, so you go plus 4 times y squared, and 4 into 24 is 6, so it's plus 6y equals negative 33. So now when you get to this point here, you want to change these into these square forms here. So that means you have to complete this square here. So when you're completing the square, you always look at the term that's not with the squared term, with the single term. So 2x, take half of it and square it is always what you do. So half of 2 is 1, and 1 times 1 is 1. So that would be x squared plus 2x plus 1 plus 4 times, okay, half of 6 is 3, 3 squared is 9. So add the 9. Okay, now since you've added here on this side 1 times 1, you're going to have to add a 1 over here. Since you've added a 9 times 4, 9 times 4 is 36, you're going to have to add 36 over on the other side. And then what you do is, when you get to this point, you factor this, and combine these. So this is 1 times x plus 1 all squared plus 4 times y plus 3 all squared equals, in this case, 4. Now when you're here, you have to remember that an ellipse has to equal to 1. Just make sure that's still in our field of view. And it is. So divide everything by 4. So this would be x plus 1 squared over 4. This would be plus 4 divided by 4 is 1, so this would be just y plus 3 squared over 1 equals 1. Now we have our ellipse. So what are the features of our ellipse? Well, our center is equal to -1 and -3. H and K right there. Okay, the bigger one, A value, A is equal to, A squared is equal to 4, and B squared is equal to 1. So C squared equals A squared minus B squared. So C is equal to, squared is equal to 3. So C is equal to √3. So now that we know √3, we can now determine what our vertexes are. Okay, we know that this is a horizontal ellipse because it's the bigger numbers under the x squared. So we have our ellipse that looks like that. Center is -1, -3. Okay, and to get the A value, A distance away, so A is, in this case, if we take 4 squared and take the root of that, A is 2. In this case, B squared is going to be, B is going to be 1. So if we go 2 away, now we're moving along the horizontal axis here. Excuse me. So if this is -1, 3, we're going to move along the x point. So this -1 plus 2 is going to give us 1, -3 here for that vertex. And if we subtract 2 from this negative, it would be -3, 3. So there's our 2 vertex points. And then we can tell that the length of the major axis there is from the -3 there to the 1, so that's 4, or twice this. Okay? And then to find the foci are C away from the center. So because it's √3, it's a little bit weird, so it's just -1 plus √3 would give us the foci. So our 2 foci, I'm going to write them down here. One would be -1 plus √3, -3. That would be 1 foci. Okay, let's make sure that's in the field of view. And the other foci would be -1 subtract √3, so be -1 subtract √3 and -3. So those are our 2 foci. Okay, and that's all the features except for maybe, what would B be if we had to figure out B? Well, B is 1 away, so you'd have to go 1 up and 1 down. So if they wanted to know the B points here, 1 up and 1 down, this would be -1, -2 if you went 1 up. And if you went 1 down, this point would be -1, -4. So that tells us that the length of that axis is only 2. And that's how you would determine all the features of an ellipse. In our next tutorial, we'll be looking more specifically at the hyperbola, which is related to the ellipse.